Now let's take a look here at example number 2, where we're going to be asked to set up and evaluate, using our calculator, an integral that's equal to the arc length for the arc of the parabola that goes from 1, 0 to 3, 2. Now again, kind of like what we did in the last video, I'm going to go ahead and just provide a really quick rough sketch of what this curve looks like, so I know exactly how I might be interested in setting up my integral. Notice that this here is going to be a sideways parabola, and it's going to actually start here at a value of 1. And I can tell that since I have a positive leading coefficient on the y, this is going to be opening off to the side. So notice that 1, 0 here represents the vertex, and 3, 2, let's suppose that that's a point over here. So let's suppose this is 3, this is 1, height 0, and this is up at height 2. And so I'm interested in finding the length of the curve that exists here. Now, on this question, you'll notice that I didn't actually specify whether I wanted this to be done with respect to x or with respect to y, which means that it's really your call as how you would like to set it up. But it's important that, again, you understand how to do both approaches, because if you just pick a favorite, then you'll oftentimes create more work for yourself. Notice here that since this is already set up in an x equals form, it might be a lot easier to set this up as a dy integral. Let's see how we could do this. We'll start by checking our important condition. We see that the derivative here is actually just going to be, I guess, just y. That means that my derivative here is a polynomial, and clearly my polynomials are always continuous, especially on my given interval here. So we can see that this is continuous on, but think carefully, what's the interval that I'm working on? You got to be careful, it's not 1 to 3, because if I'm working in terms of y, I would have to go from 0 to 2. But I'm still continuous there, and so my arc length would be equal to an integral from 0 to 2 of 1 plus a y squared dy. Now this actually looks like a super simple looking integral, a very innocent looking integral. But you might be surprised that this is probably one of the hardest integrals that I could give you this semester. In fact, this is a type of integral that you do not currently yet possess the ability to evaluate by hand, which is why on this question I've asked you to use your calculator. Now, if I did want to evaluate this by hand, you might be very surprised to know that in order to do this, we're going to have to introduce a whole bunch of trigonometry. We're going to have to use trig and inverse trig and trig ratios and a whole bunch of different things to make this possible. And we'll cover that in a much later section. For the time being, I'm just going to go ahead and demonstrate how I can use my calculator to evaluate this. Now, really quickly, if I switch over to a calculator here, some of you may already be aware of some of these button pushes, but just in case you aren't aware, this is how I would use my calculator to perform these evaluations. If you click on the Math button on your calculator, you pull up a whole bunch of different menus here, but actually in this first menu in Math, you'll notice that down at option number 9, I have something that's called FNint, and that actually stands for an integral. Now, I have a fancy calculator, and so it ultimately allows me to kind of just have this fill-in-the-blank template, and you may not have this. If you don't worry, I'll explain how you can type stuff in just a moment. But notice here, I can just start to type in exactly the integral that I had. Although here, I'm going to use x squared, because I don't think the variable matters, and at the back, as long as I do a dx, then I know that everything should work out perfectly. So I'm going to type in something like this. If I hit enter, the calculator will think for a while, and notice it will give me a rounded answer. It is not giving me an exact answer. So here, for the sake of argument, let's go ahead and round this to 2 decimal places. So that'd be 2.96. So on here, I'll just write 2.96. Notice again, this is not exact. So if I asked you for the exact area, using your calculator is not a good way to arrive at that answer. It will never tell you the exact unless you have some sort of terminating decimal. Now, if you didn't have that calculator command, it's possible that on your calculator screen, you got something that looked instead like this. You had fn int, and then you had, oops, that's int, and then you had an open set of parentheses waiting. Well, typically what you have to do here is you have to input 4 different things, all offset by commas. And I'll have to go ahead and expand this sidewall. But you'll have 4 separate things that you have to put in there offset by commas. The first thing that you ultimately have to put in is your function. Okay? So this would be, what exactly are you attempting to integrate? And then once you've typed that in, so that'd be like your 1 plus your x squared under the radical. Then you have to push the comma button. Notice that the comma button exists right above the number 7. It's right here. You can click it. It puts a comma in. And if you then go to the next entry is what's your variable that you're integrating with respect to. It kind of like wants to know, is this a dx problem, a dy, a dz? What are we talking about? So in there, oftentimes we would just put an x. And then over here, we're going to have our lower bound and then our upper bound for our integration. So in this case, I would have had something like a square root of 1 plus an x squared in x, a 0, and a 2. And that should generate the exact same answer that I have up above.